Hello, welcome to today's class. Before we start, may we start with a word of prayer. Almighty Father, thank you for the breath of life you've given unto us, Lord. Lord, as I'm going to start this class, may what I'm saying be understandable, may it be comprehensible. May you understand and be able to apply what has been said, dear Lord. Lord, I pray this should pray, trusting and believing in the name of Jesus Christ. Amen. Hello, so today we're going to talk about faulting, and under faulting, we're going to talk about the types of faulting. So in our previous class, we looked at the definition of faulting. Yeah, we looked at the definition of faulting. We introduced the topic, though we were talking about the other topic. We just did an introduction. And under here, we're going to talk about faults, the type of faults. I'm going to show you, illustrate, and demonstrate to you what is to be done and what is to be seen and what concepts is to be grabbed under this sector. So under types of fault, it happens, there are four types of fault. So there is the normal fault, there is the reverse fault, there is the transcurrent fault, and there is the overthrust fault. So we're going to start with the normal fault, and you can see on our slide over here, we can see a picture of a normal fault. This is a normal fault. Before this process happened, the land was green and the green were attached together, but something happened. The one side became lower than the other side, and right now I'm going to explain to you what happened and what transpired that caused the one side to be higher than the other side, which side moved and which side remained as it is. Yeah, that's what I'm going to explain to you right now. So it's due to tensional forces. So when I say tensional forces, I mean that the forces, they tend to go away from each other. They go away from each other, causing, when there is too much pulling, it causes the earth crust to crack. When it cracks, it causes, like, one side goes the other side, one side goes the other side. There is like loosement. There's no grip. So gravity comes in. This is where gravity comes in. So gravity takes the middle part and pushes it downwards, the part where it is loose, which is out of grip, the part which was like pulled from the tensional forces, it comes down, and this majorly makes it to, like, the resultant feature formed by this process is the Rift Valley, the famous Rift Valley, which we know, and there's submarine valleys. The submarine valleys are those which are under the ocean, the oceanic plate, yeah. And the Rift Valley is what we can see, like exogenic. We can see it with our eyes. It's a process, it's a feature that we can see with our eyes, yeah. So we all know the Rift Valley is a large feature. It goes all the way from East Africa, the eastern part of Africa, almost to the central part of Africa, going down to almost the southern part of Africa. That's how intense a fault could be. You see. So when those, like, I have to emphasize that the cracks that are formed due to tensional forces, those cracks, how they are shaped, the moving down, those what made the faults to move down, those cracks are what are known as the normal faults. As we all know, faults are fractures, the fracturing of the earth, the part which is fractured, that is what we call the faults, which comes out as due to this force. So this is the map of Africa showing. We can see the map of Africa, the eastern part of Africa. You see, it starts from there. Actually, it starts from the sea, where there was tensional forces and everything was pulled aside, leading to the formation of Rift Valley, going all the way from East Africa almost to DRC, where is the Central Africa, to the southern part of Africa. We can see, yeah, Eastern African Rift Valley. That is what we have here as an example of what I'm saying. So that is under normal faults. That is what I have to say under the normal faults. We have to remember there is the Rift Valley and the submarine valleys. The submarine are in the ocean, while the Rift Valley is what is found on the surface of the earth. So the reverse fault is like the opposite of the normal fault. We can see over here, one side is like the others, like the other example of the normal fault, one side is upper, one side is down. We have to know which side moved, which side is the original part, which side moved. When you look at the arrow, what do you understand when you see the arrow? That is what I want to explain right now and help you comprehend in your minds. So they are formed due to compressional forces. You see, they compress, they compact each other. When they compact each other, they press and causes the middle part to come up. That's the main concept that you're going to understand over here. So the forces presses the block together, making the middle part. So when they compress, and the middle part comes up, it leads to the formation of what we call block mountains. So they lead to the formation of block mountains. When block mountains are one of the highest mountainous, they form a high mountainous chain. You see the chains, they're one of the highest mountains. And over here, I didn't write it down, but let me just give you an example of examples of mountains that are considered in East Africa to be known as block mountain. In Tanzania, we have Pare and Usambara. In Uganda, but Rwenzori, we have Rwenzori, but Rwenzori, it's like in the middle of DRC Congo and Uganda. That's where we find like the Rwenzori. Yeah, there's Aberdare Ranges in Kenya. We have to know that, and that is Kenya. There's Danakil Alps in Ethiopia, just our neighbor over here. Yeah, as we have seen in that the previous map. So this one has this diagram shows a clear understanding of what I mean by the normal faults, the reverse faults. As we can see, those are the layers of the interior of the Earth's surface. These forces coming together, leading the middle part to come upwards. As we can see, there is an arrow showing that it has gone upwards, and there is the second diagram there. There's an arrow showing that it has forced the middle part to come upwards, and the sides is known as the host. So the block mountain is known as the host, and it is formed due to the compressional forces, and it has caused it to move upwards. That is the main concept we have to understand over here. So the third one, this one is an interesting one. It's not like the normal, it's not like the reverse. This one is called the transcurrent. It doesn't cause the features to go down or up, or it just makes it slide over each other. Like they just move, but in a lateral manner. Like they just slide over each other, they glide over each other. That's the main concept when we talk about the transcurrent slip fault. So it's known as, it has three names. The name is namely the transcurrent fault. There's the strike slip. There is the shear and tear fault. This one, they are mainly known for their lateral movement. Yeah, so the forces causes it to move in a horizontal manner. That is the main concept that we have to understand when we talk about the transcurrent, the shear, or the strike slip fault. Yeah, that is what we have to understand. So there is the overthrust. If we have an understanding of the previous, of what we have talked about previously, we will get to understand this picture. As you can see in this picture, that is the interior of the Earth's surface, where we can see the lines inside, not the ones which are on top. I mean this one. This is the inside of the Earth's surface. Something happened. You can see they're at an angle. Yeah, there's some forces which has caused them to be this way, not like the other diagrams. This one looks to be very interesting. So let us look at it and see how different it is from the other ones. What causes it to be like this, not like the other ones? Let us see. It is due to compressional forces, whereby the compressional forces at one side is greater than the other, which is on the other side. When one side is greater than the other side, means there's greater pressure on one side to cause the movement of the block to move more on one side than the other side, which means movement will be more on one side, making it to be like not equal. So when the compression force is too much, it like forms and it curves, and it forms like what we've seen here. It is at an angle. Yeah, so they lead to the formation of a block that is overly laid on the other block, making it to bend at an angle. That is the main concept you have to understand here. So the overthrust leads to the formation of escarpments. That is what we have to understand. And the famous escarpments we all know is the Aberdare Ranges. Yeah, the Aberdare Ranges is what it's commonly known and what we commonly understand. That is what I understand. Yeah, and there is the Mau escarpment. You get it? So there is the overthrust. I want you to look at this and get this picture into your mind. Okay, I want us to get a recording to get to listen to this video and understand better of what we have talked about, so that we can greatly understand of what I'm saying over here.
Hi guys, and welcome to today's tutorial. In today's lesson we're going to look at the different types of faults that you can get. Okay, so we're going to look at different types of faults, okay? And faults are grouped according to the type of movement that they have. We're going to look at three different types of faults. We're going to look at a normal fault, which is this one here. We're going to look at a reverse fault, which is this one here. And then we're going to look at a tear fault, which is this one here. Okay, so let's write this up for you. So you've got a normal fault. You've got a reverse fault. And you've got a tear fault. Okay, so we're going to just talk about each one of these now. The first one is a normal fault. A normal fault happens when happens at constructive plate boundaries, where there's lots of tension, where the plates are pulling apart. And these result from the tension stretches as the plates pull apart. And what happens is the movement is normally vertical. Okay, so you can see that the movement here, the fault line, is like it's vertical. And what happens is one block slips down past the other one. So this one here used to be in line with this one up here, but it's actually after slipping down because of the tension as the plates pull apart from each other. The next one we're going to look at is a reverse fault, and reverse faults happen at destructive plate boundaries, so the two plates are crashing into each other at destructive plate boundaries, and lots of compression, there's lots of pressure builds up. What happens here is the movement is vertical as one block of rock is forced up onto the other one. Okay, so this block is being forced up onto this block here. So because of the compression of the two plates at destructive plate boundaries crashing against each other, it actually forces this block onto the other block. And the last one is a tear fault. And a tear fault is when happens at conservative plate boundaries, when plates are sliding past each other. And what happens here is you get the tear fault. It's a horizontal fault. Because the plates are moving in opposite direction, a tear fault here just forms. An example of this is the famous one is the San Andreas Fault in California in West America. So, as you can see from these three, you see where the black line is here, they're the different faults that you get. Okay, so you got the normal fault, the reverse fault, and you've got the tear fault. And one thing to note is that these lines of weakness where these faults actually develop can be further helped by weathering and erosion, because the weathering the elements can get into the fault lines. So weathering and erosion does become very effective and does actually help to make the faults bigger. Okay, so that's it for today's tutorial. I hope you enjoyed it. It was a really short one on the types of faults that you can get. So we looked at the three different types of faults. One that you get at constructive plate boundaries, destructive plate boundaries, and conservative plate boundaries. If you enjoyed it, can you please leave me some feedback? Can you tweet us at ExamInVision for you? And can you follow us on Facebook at ExamInVision?
Yeah, so that is basically what we've been talking about today, though it has not addressed on one. Yeah, it has not addressed on the overthrust, which this is mainly because an overthrust is it gives an example. It comes from the formation of a reverse fault, as we have seen. So we've talked about as we can see, the black line that cuts across the interior part here, where is colored, called the interior part of the earth surface, that black line is what we call the fault. That is what I mean when I say the fault. How they are shaped, how they move, that is what they give them their types, of which this, as we have seen, how they move is what gives it their title. The intensity of the forces is what can also help them determine whether it will be a reverse fault, a normal fault. The intensity, you can see if like the types of forces also plays a major role on determining what type of it is. So a recap of what we've done today. So we have talked about the normal fault, we've talked about the reverse fault, we've talked about the transcurrent fault, and we've talked about the overthrust fault, where the normal fault formation is due to tensional forces when the forces are moving away from each other. And when you talk about the reverse fault, these ones, compressional forces, they're pressed towards each other, they're pressed. So when they're pressed, there's the formation of block mountains. That's the clear concept that we have to understand from here. And there is the transcurrent, the slip, the strike slip fault. Also, it has like 3 names: transcurrent, strike slip fault, or the shear fault. This is one fault. It's only that it has a variety of names, but you have to choose one when you want to try to describe what we are saying over here. And the last one, where the transcurrent, we've said it happens due to the lateral movements. The forces make it to move lateral, horizontal from each other. There is no formation of a feature moving upwards or a feature moving downwards. That's the clear concept over here. And then we come to the overthrust, where the compressional forces are more on one side than on the other side. This is the clear concept over here, which causes it to be in the formation of a fault. That's what I had to say today. Thank you for listening. May you have a lovely day. Thank you.